Hello again. In this video, we'll learn how to program a compact Logix PLC to input and output analog voltage signals. The first thing that we must do is to start up Studio 5000 software. Click on the Studio 5000 icon, click Yes, and then we're going to start a new project. So click on New Project. And you must use this particular PLC, the 1769 QBFC1B, and give it a name. We're going to call it Lab 4. Then click Next. Just verify here that this is version or revision 34, and then click Finish. Once the software has loaded, you will see the controller organizer. And the first step within the controller organizer is to set up the path. And you do that by clicking on this little network icon up here. And eventually this will open up and we select Ethernet IP1 right here. You may have to scroll down the list to find this one that has the 192.168.1.30. But once you do, click on it and then say Set Project Path. And then once you have set that project path, you can close this window. And you'll see up here that we do have that project path. The next step is to go to the main program, click on this, and eventually main routine, and here is our blank program. Before programming, we must configure the analog input and output modules. And we do that by going to slot 2, which is right here, embedded analog I/O, right-clicking on it, and setting up the inputs and outputs. You'll see on the top here, there are many tabs. We're going to start off with General, and we're going to just put Analog I/O here. And then we have to go to the input configuration, and we're only going to be using one channel, which is going to be 0. There are 4 of them on our PLC. So I enable the channel. I have to select the range. And for what we're doing in the lab, we're going to use 0 to 10 volts. But you can see there are many possible ranges. The next thing that we're going to do is make sure this filter is turned on, 60 Hertz. The data format, we're not going to use the default raw proportional. We're going to change it to engineering units. And we want to enable the open circuit response. And once we've done all that, just click Apply. And next we want to configure the output. Go to here and we're going to use channel 0 output, select 0 to 10 volts, and again we're going to use engineering units and click Apply. Now when you do, you'll notice this error here because we now also have to set what's called the clamping value, and that's the value that the output will go to at maximum and at minimum. So I'm going to put a high clamp of 10,000 representing 10 volts and a clamp of 0 representing 0 volts. And now I can say OK. All right, so that concludes this part. All right, this step requires that we remove or delete this program rung. So I'm going to do that. So right click and delete rung. And now we can download this program and it won't have any errors. So as long as we have a path, we should be able to now go to download. Takes a few seconds. Okay, once we get this message, click on the download. And now click Yes. And you should notice here that we're in run mode. The controller is okay, I/O is okay, and it says remote run. So that allows us to use the PC to examine some of the controller tags. So I'm going to go to controller tags. And we've done this before, so I could have a look at the input tags and the data for the digital input. This tells me the state of all the digital inputs. I can close this off. And this is going to give me the state of the digital outputs. And these are the binary values. So this is where I could actually change output values. But today we want to look at analog I/O. And the analog I/O begins here at local 2 input and local 2 output. And we're going to start off with the output. So you can see that there are actually 2 channels that are important to us. Local 2 output channel 0 data and channel 1 data. So here I'm going to modify the output on channel 0 data. If I want to send out 4 volts, I have to type in 4,000 because each millivolt or each integer represents 1 millivolt. So 4,000 represents 4,000 millivolts, which is 4 volts. So I've written that value to the output. If I connect a voltmeter, I should read 4 volts. Now on this particular machine, I have a device called a loopback, which is sending that signal back to local 2 input, channel 0. So if I go to that channel, you can see, I see a bunch of numbers here, but they're in binary. Binary is not a good way for humans to read the data, so what I'm going to do is switch the style from binary to decimal. Okay, and I hit the wrong one there, but I can do it to this one. And what you notice here now is it's reading back 4009, representing 4009 millivolts or 4 volts. And you'll notice it's not exactly 4 volts, it's 4.009, but that's a very small error. Okay, no need to worry about that. If I go back, I'm going to close this window again. Okay, and go to local 2 output once again, and we'll change this to 6,000. Okay, you have to make sure you hit enter, close this window, go back to this one, and you can see it's 6,000, which is 6 volts. So if I were measuring this output voltage, I would see 6 volts. Okay, our next step is to create some variables. So we're going to go offline. We're going to go to parameters and local tags. And you have to come down here to edit tags, and then we can type in some names. So the first tag I'm going to create is called analog in underscore channel 0. So that's going to represent our analog input. And it's going to be an alias for the tag for the analog input, which is channel 0, and it's channel 0 data. Okay, the next one is going to be analog out. So I'm going to go to analog out, channel 0, and it's going to be an alias for this time the local 2 output. So scroll down a little bit till you get to local 2, expand, and this is the channel we want here. Okay, and notice that both of these, the data types are integer, and we want the style for actually both of these to be decimal. So I'm going to change this to decimal. So this is the basic setup for the analog in, analog out. These are the proper channels. I can move this over to see the whole name, but this is set up correctly. The next step is to have variables for voltage. So I'm going to call one of them volts in. And this is going to be a base tag. This one's going to be volts out. But I want to change it from an integer to a real because our voltages are going to be real values. So you can just type in a few letters for real and then click OK. Same thing here, real, and just move away from that data type. So everything is as expected here. It's a floating type, so it's going to have decimal points. We don't have an alias for it, so I would consider this the base tag. Okay, once you've done that, we can close this window and go to our routine. All right, in this part of the video, I'm going to create a simple program to control the analog outputs. So the first thing I want to do is to add a rung. Okay, so we're going to click over here. I'm going to add a rung, and I'm going to add a bit instruction. I'm going to start off with an examine if open. And I'm going to add a compute instruction. And the instruction I'm going to add is this one right here. And my destination is going to be analog out. So I have to type in, and I have a variable already called analog out, but we have to change this so it says out, and it's channel 0. So all of that's okay. I can just click here, and the expression that the voltage that I want to send out is going to be 4 volts. So I type in, well, let's actually type 4,500. which is going to be 4.5 volts. Okay, and I want to do it whenever push button 0 is pressed, and push button 0 is normally open. So when it's not pressed, this should be true. And I'm doing this because I'm setting up this program remotely. So I'm going to type in PB0. Okay, and that's a new name. That's why this line is still red. That name we've defined before, but this name is new. So I right click and say new push button 0, and it's going to be an alias. So I change from base to alias, and I look up, and I know that it's 0. So I'm going to go to local 1 input and data, and the bit I want to select as 0, and then do create. So once I've done that, that's the end of my program. I can try downloading it. Hopefully there are no errors. So it's downloading now. So what this program should do is cause the output to go to 4.5 volts. And we're going to test it by going to the controller tags to see if the controller tag has that value. Okay, so you can see that push button 0 is normally open, so it's going to be true. It's causing 4,500 to be sent to this port. Okay, and if I go to the controller tags and I go to local 2 output, you can see it's at 4,500. And if I go to the controller tag input, because if you recall, I do have a loop back on this. Oops, the wrong one. Here we go, and our loop back is reading the correct voltage. Minor offset, okay? This is only 9 millivolts out of 4,500, so a very small percent error. Now there is another way I can write the same thing. I'm going to go to the the program tags. These are the ones that I've created, okay? And you can see there's one called volts in and volts out. So I'm going to change this volts out, and I have to be in monitor mode to do that. So I'm going to change it from 0 to, let's say, 6.7 volts. Okay, and then just click on anywhere else. So 6.7 volts is the output that I want to have. So I go back to the main routine, and I'm going to change the expression here to volts out. So I'm going to use that tag. And I need to multiply it by 1,000 because 1 millivolt is, or an integer value of 1 is equal to 1 millivolt. So if I take the 4 point, whatever value I used, and multiply it by 1,000, it should give me the correct voltage. So I'm going to download this program to test it. And click download. And this time it should read the volts out variable. It's going to be multiplied by 1,000 and sent to the analog out channel 0 register. So you can see here that it's reading 6,700 because if I go to the local tags, I have 6.7 volts that I want to send out. So that's a value in voltage or engineering units. If I go to the controller tags, I can see, if I go to local 2 input, it's reading 6,700, representing 6.7 volts. So just as I expected. All right, in this part of the program, what I've done is I'm going to read the analog input on channel 0, divide it by 1,000 so that I get it in a voltage value, and I'm going to store it to this volts in variable. So let's test it out. So I'm going to download that. And don't forget, you can always hover over variables to see their state. So that's what I was doing here, just hovering over the variables and going to the controller tags and local tags. Those are always great ways to see what's happening in the program. Okay, so here you can see I have 2 lines of code, and here I'm reading the analog input. And you can see it's 6710, but we're dividing it by 1,000 to get it in voltage, and my voltage is 6.71 volts. very small error, and that's probably just due to the wiring. Now that we've done that, we can go one more step and use a compare instruction. So I'm going to stop my program. Okay, I'm going to add another rung. I'm down here to add another rung, and we're going to do a compare instruction. So that's right here. I'm going to drag it down here, and I'm going to add an output instruction, which is going to be under my favorites. And I'm going to turn on a light whenever the voltage is greater than 6 volts. And don't forget, I'm doing this remotely. So I've written a bit of the code. So the comparison instruction has an expression, and my expression says when volts in is greater than or equal to 6 volts, we want to turn on this light. Now, I haven't used this light before, so I have to say new light, and it's going to be an alias for a bit in the hardware. So it's an alias for local 1. In this case, it's going to be an output data, and I'm going to use the first light, which is bit 0, and do create. So now you see that there are no errors. So what's going to happen here is it's going to read the volts in, which I've done over here. If it's greater than or equal to 6 volts, it's going to turn on light 0. Now it should be, because volts out was 6.7. So I haven't downloaded this. So let's download and give it a try. Don't forget, like I said, hovering over the variables is very helpful in troubleshooting things. And don't forget to use the inhibit mode. That's very useful also for controlling analog output. Okay, now that our program is done, you can see here it's doing what I expected. So this push button is not being pressed, but it's normally open. So this goes true, causes this compute instruction to be executed. And my V out is equal to 6.7 volts. So 6.7 times 1,000 gives me 6,700, representing 6.7 volts. So that was my output. And since I'm using a loop back, that's what I'm reading. So 6.71 volts. If I go to this register, it's an integer value. Notice it has integer. It's a local tag, and it gives the name of the tag, the value of the tag. So that's why hovering is very good. Even over here, if I hover over this variable, sometimes you've got to go back and forth so it reads it correctly. So here it's showing me my volts in currently is 6.71. So that's greater than or equal to 6. So the output of this compare will go true, which causes this light to be turned on. Okay, but if I have these inputs and outputs separated, one connected to a power supply, the other connected to a meter, I can monitor what's happening. Okay. So that's basically it for this part. The next part of what we're going to do is to create a trend to monitor our voltage. And in this example, we're only going to monitor the input voltage. So to create a trend, you'll come over here to Assets, you go to Trends, you click on it, right click, New Trend, and we're going to call it voltage. Okay, and sample period of 10 milliseconds is okay. That just means every 10 milliseconds we're going to read the analog input. Once you've done that, click Finish, and you end up with this screen. First thing to do is we're going to switch the color of the chart, and that's done by, let me slow that down a little bit. Right-click anywheres on the chart, go to Chart Properties, and Display, and just change the background color to white. Okay, and then click OK. And then the next thing, we're going to modify each of these tabs here. So we're going to go to the pens first. And the pens are what draw on the screen. Okay, so to add a pen, we need to add and configure tags. There's a couple ways of doing this. We're going to go to Lab 4, but we're going to go to the program, and we're going to find the tag for volts in. So we're going to select that tag and click Add, and it should appear in this window. Once you do that, select OK. So you want to make sure that you do have a tag there. You can slide this over, and our scale is going to be different than the default. We want it to be a maximum of 10 volts. So I'm going to change it from 100 to 10, just hit enter and just go off of that block. And we can also add the engineering units here and say volts, because that's what we're using. And I think that's all we have to do for that tab. So click apply, and we'll go to the X tab, and we want to have 2 seconds. No, that's too short. So we're going to put a minute and change this to 1. So 1 minute. And we don't want to display the date on the scale, but we do want to have 5 major grid lines. And what that will do, and if I click OK, you can see here we have 60 minutes, 60 seconds, or 1 minute across the screen. So each of these boxes represent 10 seconds worth of time. So 10, 20, 30, 40, 50, 60. And so that tab is okay. Next one will be the Y. And we want to have 9 major grid lines, which is going to give us 10 spots. Let's go to 9 right here, click apply. And you can see this is going to represent 0, 1, 2, 3, all the way up to 10 volts. The other thing that's important here is to set the preset based on the pins. Okay, and once we do that, if I just move this box over here, you'll see it goes from 0 to 10 volts. Okay, so this here tells you the color of the pin. In our case, it's going to be blue. The other thing that you need to add here is the resolution. And you change the resolution right here under decimal places. And we only want 1 decimal place. That'll be fine. Okay, and I think those are all the tabs. So let's just review. We've called it voltage. And it's a standard chart style. Under our display, I think the only thing I changed here was the background color to white. The pins, you just want to make sure that you have 1 pin for volts in. You can add and configure the pins here. The other thing that's important for this pin is the scale, and we can move backwards. And I've added the engineering units, but you can see our scale is 0 to 10. That's really important for this to work correctly. And the x-axis, the more important thing here is that we have 5 major grid lines and 1 minute time span from the left to the right hand side. It's kind of like a scope. The y-axis would represent the amplitude, in this case volts. We want to preset it based on what we've set up in the pins. We want to give it a decimal places of 1. And I think that's all that we've changed here. So once you've done that, and this is the most common thing students forget to do, is to click on Run. Now what will happen is our voltage appears over on the right here. Our pen is over here. So 10 seconds will have gone by as soon as it hits this line. So 10 seconds, that's 12, 13, 14, 15. So it's drawing our trend chart. Now, you have to remember I'm doing this remotely, so I can't change the voltage of the power supply, but I can go into the local tags and change this voltage. For example, the volts out, I can change it to 6 volts and see what happens in my trend. So go back to the trend over here, and you see it changed to 6 volts. Okay, and it stayed at that voltage for about 8 seconds now, 9, 10. I can go back to my local tags, and let's say I want to change this to 7.5. Okay, in the lab, you will be doing this by changing the knob on a voltmeter. Now make sure you don't exceed 10 volts. That again can damage the PLC. So I go back to my trend chart, you can see I'm at 7.5 volts. Now, when you're using the power supply, you'll get much smoother curves as this changes. Hopefully, these few demos will help you out with lab number 4. Part A is working with analog I/O, and the second part will be working with temperature.